Alright, moving on. As I mentioned previously, petroleum geochemistry offers low, rapid, and low-cost evaluation tools to aid in understanding development and production problems. So, as a petroleum geochemistry in development team, your task would be different from those who are working in exploration team. So, in general, your scope of work would be assessing the oil quality. Okay, you need to determine the vertical and lateral variations, and next identify fluid content and predict currents and quality in contaminated samples. And then you need to assess the reservoir compartmentalizations, investigate oil field brine, and identify the solid bitumen in reservoir. So we go for the details for the duties. Alright, the oil quality here refers to oil gravity and viscosity. Why do you need to know these two properties of oil? Because first, both properties are strongly impact the economic potential of an oil accumulation by affecting the oil value and processability. Second, these properties of oil can control the choice of choosing which reservoir interval to complete in which well. And third, the difference of these properties are controlled by first, differences in oil source rock characteristic, and second, post-generation processes that will reduce the oil gravity and increase the oil viscosity. So the post-generation process here refers to the oil biodegradation, okay, evaporative fractionation during migrations, reservoir deasphalting, and water washing at fluid contact. Alright, the oil quality can vary vertically and laterally. So part of your duties is to identify these variations. So how this variation happen is first due to distance from oil-water contact. Okay, biodegradations occur at or near water contact normally, and thus the biodegraded oil columns vary in compositions with grade, with most of the biodegraded oil occurring near to the oil-water contact. Second, parcels nature of reservoir filling. So all fluid properties here vary with the reservoir filling history. Primary charge exposed longer to the biodegradation process than secondary charge. So meaning here, a biodegraded oil column may consist of a mix of oil that arrived first in the reservoir, which we call it as primary charge, and there is also subsequent pulses of oil that arrive later in the reservoir, which we call it as secondary charge. So the primary charge may be more biodegraded than the secondary charge because it has been subjected to in-reservoir biodegradation for a longer period than the secondary charge. Thus, these both reasons may cause vertical and lateral variations of fluid properties. So the technique used to solve this problem is by using oil geochemistry. Okay, it's just the same thing as oil biomarker. Alright, so part of the assessing of oil quality as a role of development geochemists, you need to identify the fluid contact, as this is also will affect the properties of oil. So as a petroleum geochemist, you need to have an understanding of the oil quality in an accumulations or traps. So to do this, the technique that you will ultimately use in the industry are by integrating the data on wireline log. Basically is you will use this wireline log to assess typical type of reservoir fluid in sand shell sequence by using combinations of neutron density tools to detect low hydrogen and low electron density, and RFT, repeat formation tester, which you will use sample acquisition technique and pressure gradient to assess the typical type of reservoir fluid in sand shell sequence. Next, you will also use the geochemical core extract, where you will use all geochemistry technique for residual hydrocarbon from sidewall core to know the properties. Okay, the oil quality also varies due to the contamination, drilling, additives, and mix with or displace the in situ fluids formations to the oil, which will affect on the properties. So presently, they usually use non-water based mud for drilling process. There are two main types of base mud that they are using. The first one is oil based mud, okay, which incorporate diesel and petroleum minerals all as their base. However, both this ingredient or this content giving harmful to environment and require complicated disposal procedure. Second one, they use synthetic fluid based mud, SBM, which they use a olefin, ester or ether as their base. However, this type of base mud are expensive, okay, because it's lower toxicity, but yet it faster biodegradability and has a greater potential for recycling. Alright, the purpose of they use these base muds are to first to get consistent drilling performance, okay, and then it will actually facilitate drilling by become cleaner, more stable holes can reach difficult horizontal extended well. It also can minimize the incidence of stuck toe, and using that also it can create a lower volume of drilling cutting, and these drilling base mud are enabled to actually recycle for multiple uses on multiple wells. So to identify the oil quality from the contaminated oil samples due to drilling additive, usually industry people will use oil geochemistry. However, the prediction of oil can be successful if drilling contamination is low and OBM base comprises only a few components and there is no biodegraded formations and a moderate gravity value in oil. Alright, your second task as a development geochemist is to assess reservoir compartmentalization. So what is reservoir compartmentalization? It is actually here refers to the presence of fluid flow barriers between two fluid sampling points. Okay, why do you need to know this? It's very simple because you need to understand as it serves as useful independent line of evidence for evaluating reservoir continuity that will ultimately give implication to other data types. And secondly, it is useful to determine sealing capacity of potential non-flow barriers by integrating together with geological and engineering data. Right, how does the reservoir compartmentalization occur? Simple, it can be happen in an accumulation because all may be derived from different source rock. Thus, the composition may also differ because there are different types of generations and migration path. Therefore, an accumulation or trap in a basin will have different mixes of oil, and these differences may result in variations of oil quality within and among the offshore oil field. Second, all may derive from the same source rock but different level of maturity. As I mentioned previously, source rock will generate the oil at a given time different from the previous generated oil and subsequent generated oil. Thus, this makes the difference of oil composition. Okay. The third one is the composition difference arises due to post-in-place alteration processes. Okay, which means here the source oil from different compartment of reservoir may have different exposure to the process of biodegradation that will affect the oil composition after the oil enter to the reservoir. And the last one is the filling history consideration. You have to remember that every compartment has their own identical geometry and filling history that will lead to differences in oil composition. So the technique that we use to assess the reservoir compartmentalization are by integrations of geological and engineering knowledge using wireline log, 3D seismic interpretation, and pressure data. And we will also use geochemical to actually assess on the gas composition, isotopic composition, okay, between carbon, the ratio of carbon hydrogen in specific gas species, like for example methane, ethane, carbon dioxide, and also ratio of carbon and hydrogen in gas condensate. For example, we use paraffin component. And then we also use gas chromatography to assess on the oil geochemistry and gas condensate. Right, the third scope of work as a petroleum geochemist in development team is to investigate oil field brines. So oil field brines here refers to the water formation which the origin is from fresh water to highly concentrated brines. So the characteristic of these water formations are basically chemical traces that occur naturally, which include the absolute and relative abundance of various dissolved salts, anion and cation, and then isotopic composition of certain cation, for example strontium 88, 87, 86, and also hydrogens and oxygen of stable isotopic composition of the water itself. So the impact of oil field brines ni, it will cause the water flood at the oil field, and the method to actually overcome this problem is by assess all the water geochemistry that can be taken from the oil field flooding. So your task as to prevent from water flood at the oil field is you need to actually identify the origin and track the movement of the water in oil field. And then second, predict and justify the formations of rock that is responsible for water moving behind casing. And last one is diagnose and predict the cause and scale of other mineral precipitation in flow line, valve, gorge, and other surface equipment. Alright, as the last duty for a petroleum geochemist in development team, you would need to identify the presence of solid bitumen in reservoir. So solid bitumen here refers to a reservoir altering cements or fluid barrier. So the characteristic is actually it formed by natural or artificial alteration process, by thermal cracking, which formed by pyrobitumen, by disalphating process, which will form the migrabitumen, and by the water washing, which will cause or will form the tarmac. So how does the solid bitumens look like? It actually looks like droplets or grain coatings or honeycomb fingers-like bodies, which will reduce porosity and permeability of the reservoir rock. And then it also can be found finely dispersed and localized in porosity and particularly interval, which potentially will create a fluid barrier in the reservoir itself. And it also can be found vary in chemistry with different impact. For example, it will form by different processes, so it will give different impact to the producibility of the oil. So the impact of the formations of this solid bitumen is it will reduce porosity and permeability significantly, which the petroleum, you can get the petroleum with the moderate amount. So the task in assessing the impact of the presence in oil is by assessing the properties and distribution of this reservoir bitumen type, bitumen solubility, formation mechanism, and volume of distribution in the reservoir. And we have two techniques to evaluate to overcome this problem. The first one is For the evaluation part, we will analyze the sidewall core